Oops, wrong one there. All right, just going through a few questions from exercise 6C, question 7. Let's just have a look at how we do these ones. Composite shapes, they've asked me to find the area. I'm just going to find the exact values. I'll leave you to push buttons on your calculator. All you've got to do with these ones, break them up into sections and then add the sections together. I'm just going to label them 1 and 2. You could use little semicircle and square when you were writing it, but the total area is going to be just the area of section 1 plus the area of section 2. Just making it easy for someone to follow my working. The first bit I've got is a semicircle. So it's going to be half of the area of a circle, which we know is pi r squared. Squared, that's the one that refers to the area because it's got 2 dimensions. 2 pi r, that's the circumference because it's only got 1 dimension. The other shape, area 2, is a square, so that's just going to be the side length squared. Something like that. We can fill in the blanks. You don't have to write that line in, but if it helps remind you of the rules, then I would encourage you to do so. So my area is going to be 1/2 of pi. Now how big's the radius? Well, the entire length is 5. It's up to you if you want to use 2.5. When I'm doing them without a calculator, I'm probably going to use fractions. So I'm going to go with 5/2, and I've got to square that there. And then the side length squared, well, that was just 5 squared. Happy for you to write 5 times 5. Still going to give us the same answer. We go ahead and we do our calculation. 5 squared is 25. So in the numerator, I've got 25 times pi times 1, so it's just 25 pi. And in the denominator, I've got the 2 squared from the fraction. 2 squared becomes 4. Multiplied by another 2, that's going to be an 8. And then I've got 5 5s are 25 at the end. That's my answer. Include my units. That's how many square centimetres the area of that shape is. If you wanted to write that as a single fraction, you could, but there's no need to. Again, here I'm going to have 2 areas, area 1 and area 2. The total area is going to be area 1 plus area 2. First area is a rectangle, so base times height. Length by width, whichever way you like to think about it, 4/7. The next one, the triangular area, I've got 1/2. The base is 7. Now the height, it's not 10. 4 metres has already been accounted for by that rectangular portion, so the remaining portion, make sure it adds up to 10, is 6. So the height of that triangle must be 6. And now we just go ahead and do the maths in our head again. 28 plus, I'll go half of 6 is 3. 3 7s are 21. And if I add 28 and 21, I get 49. This time my units are metres, and of course it's an area, so it's square metres. Breaking them up into sections, adding them together, that's our key. Third one here, they've given me the radius of the circle, but to recognise that other shape, I might need to just think about the total distance across there. 1.7 plus 1.7, that's 3.4. Again, indicate which areas we're finding, communicate your working. In whatever way you think is most convenient, you could just use colour coding if you wanted to. That would be fine if you've got a highlighter or shade it or something like that in your exam. As long as it's easy for anyone to pick it up and understand what you're doing, they'll be happy. A semicircle, so that's 1/2 of pi r squared. This time my radius is 1.7 squared, so 1/2 of pi r squared. Then we have a trapezium. It's turned on its side, but that's still, it's got 2 parallel sides. So we find the average width times the height, or in this case, I guess it's the average height times the width. So how do I find that average? I've got 3.4 for one length, 1.8 for the other, add them together, divide by 2, a plus b/2 times the height, which is 1.6. Oh, that's going to test me out. 17 or 1.7 squared, 2.89. So I'm going to have 2.89 pi divided by 2. Not great to have decimals mixed in with our fractions there. I could have changed 17 to 17/10 and done it that way. That would work as well. Or you could just neaten that up. If I just multiplied top and bottom by 100, I'd have 289 pi over 200. That's another way you could do it. But for the purposes of what we're doing, 2.89 pi over 2 is okay. I haven't done the second bit yet though. 3.4 plus 1.8, 4.4, 5.2 divided by 2. I make that 2.6. I've got to multiply 2.6 by 1.6. That does not look like fun, but we can do it. I'll show you my favoured way of multiplying these numbers. I like to draw a little grid. Maybe not the same way you've seen it before. It doesn't really matter. We all know how to multiply. And then in each box, I just go like this first box, 2 times 1 is 2, 6 times 1 is 6, 6 2s are 12, 6 6s are 36. And then you just add up going down the diamonds, the diagonals of those squares. So 36, I put down the 6 and I've got to carry 3. 12 plus 3 is 15, plus another 6 is 21. So I put down the 1, carry the 2. 2 2s are 4. Now I had 2 numbers after the decimal places, 1 in each number. So this is going to be not 41.6 or 416, but 4.16. We keep the same number of digits after the decimal places. So there we go, plus 4.16. These are my units, square metres, done. Nice exact value. Sort of, I do have I have a fraction and a decimal, but that's exact. You can find an answer on your calculator as long as you've got the method right. I will be marking you correct. This one here, slightly different. I've had some bits cut out. In fact, I've had 4 quarter circles cut out. What is important is these little dashes that tell me all of those distances are the same. So 4.2, 4.2, 4.2. If I wanted to have the entire length of this square, 3 times 4.2, that's going to be 12.6. So to find this area, I might say that area is equal to the area of the square, including all those missing bits, and then it's minus 4 quarter circles, but 4 quarter circles just make 1 circle. So I'm just going to say minus the area of the circle. So I'm going to have 12.6 by 12.6, that would be the area of the entire square that I've dotted in there, and minus the area of the circle, which is going to be pi times 4.2, that's the radius squared. I'm going to leave you to figure that out. Again, I don't have a calculator here, so that's why I'm going to do it. And I've shown you how to multiply, you can do that now. But the thinking behind how you get to the answer is important. If you've got that right, we are all sweet and ready to go. Ooh, this is an interesting shape. I clearly have a nice quarter circle there. So I'm going to keep that as my first little bit, but it's a little bit tricky here, isn't it? Because they haven't actually shown me what the radius is on the bottom. If I'm just looking at the bottom, I'm saying, well, they've given me 26, but that's not the radius. They've given me 28 at the top, but I haven't got the whole distance across, so I don't know how much there is. But where have they given me the radius? That's right, the height there, 18. So if this is 18, this section here must also be 18, which is now going to let me find the remaining bit. 18 plus 8 would make 26. Now the shape I've got on the right there, I'm just going to highlight it in green, or colour it in green to make sure you can see what I mean. That is still a trapezium. A trapezium consists of one pair of opposite sides that are parallel for a quadrilateral. And I have that. The 8 is parallel to the 28. Usually we think of a trapezium like this, but there's nothing wrong with a trapezium having a flat edge on one edge. And that's all we have there. We have a trapezium with a flat edge. So that's the rule I'm going to be using when I break this up into the 2 areas and go through the process that we've gone through in all of the other questions. So let's have a look. The area of the first section, or the area total, equals the area of the first section plus the area of the second section. That's going to be 1/4 of pi r squared plus, what's my rule? A plus B, the average width. So I've got to go add the 2 widths together divided by 2 times it by the height. Oh, we can go ahead and figure this out now. 1/4 pi by 18 squared plus A plus B, I've got 8 plus 28 divided by 2, find the average of those, and then I'm multiplying that by 18. And that's going to give me my answer. 18 squared, 324. Then I've got to divide it by 4. That's going to give me 81 pi. 28 plus 8 is 36. 36 divided by 2 is 18. Oh, look at that. That worked out pretty nicely, didn't it? 18 times 18, 324. Those square numbers, you're going to need to know them. And these are square kilometres. That's a pretty big area. It must be a nice field or something. I don't know. Maybe not very nice field, but it's a big one. It's in square kilometres. Lucky last, F. Here I've got a semicircle and I have had subtracted from it. I'm going to go for the green area, green line again, just to show me what's been subtracted. Oh, it's not a triangle. It is another trapezium. So, okay. My area is going to be the area of the entire semicircle minus the area, and I'm even going to orient my trapezium the same way just to make it looks almost the same as my semicircle. I need to be a bit more careful there. There you go. I guess that looks like a trapezium. I'll try it one more time. Middle side, longest. That's nicer, isn't it? Not so curved, not quite as curved, maybe. Hopefully you know what I mean. So my area, half a circle is 1/2 of pi times the radius. They gave me the radius was 0.7, so I'm going to put in 0.7 and square it there. And then minus the average width. So the total long base length is 0.7 plus another 0.7. So that's going to be 1.4 plus this little short bit at the top is just 0.25. Divide that by 2, multiply it by the height, which is 0.3. I'm going to leave you to push buttons on your calculator to figure out that one. That would be a calculator question in the exam. You can go ahead and do it without a calculator because it's always fun to practice. But I think if you've seen those now, hopefully you've got a bit more confidence and understanding of how to go about doing those questions. Please keep the questions coming. It's great to see you guys starting off the year well, working hard. I'll see you whenever I make a next video. Ciao for now.